Hello everyone, welcome to a physics problem. We have a person who is of 75 kilograms of mass is walking up a staircase 29.0 meters. What is the work net, or the net work done by this person? So we know that work is equal to, and we can use the idea that it's equal to the change in kinetic energy plus the change in potential energy. Now, I want to make a point here, and we're going to say the net work done. The net work done, his kinetic energy, is his kinetic energy changing? He starts at rest, and he ends at rest, right? When you get to the top of the stairs and you're done walking up the stairs, are you moving anymore? No, you're not. Now you require some kinetic energy to get up there, but if you took a timestamp from the time you're down here to the time you're up there, your kinetic energy would equal to 0. So this drops out of the equation. So work net is really equal to the change in potential energy. Now, what is potential energy? Potential energy is the mass of the person, whatever the gravity is, and on Earth, that's always 9.8 meters a second, times the height due towards a ground. So we're going to assume that this is the ground level right here that the guy's starting on, right? So let's work through, let's draw out the potential energy idea for work net. So we know that for a change, it's final minus initial. Okay, so what is his final mass gravity height? Well, we'll just write that for now, mass gravity height F, HF. We're going to subtract that by his initial mass gravity height, so H naught. So really it's just a difference in height here, but we still have to write this out to put it in terms of a Newton meter, right? Because work is really just equal to force of a parallel force in the direction of movement times the distance of which you've traveled. That's work. Okay, so work net, we're going to say, is equal to the 75 kgs. And we're actually going to factor out, let me back up. We can actually factor out a mass and a gravity, right? Because if I took mass times gravity and I times it by HF and times it by the subtracted term H naught, well, you get the same term. So this is an equivalent expression of the work net. So it actually saves us some time when we get here. That's why I did that, 75 kgs. There's 9.81 meters a second for our gravity. And then the change in height, it's 29 minus 0. That's 29 meters. Okay, now let's plug in for the work net. This is a Newton times a meter. That's going to give us Newton meters. That's how we know we're doing something, right? 918 times 29. We get, he needs to do this much work. 21,337 Newton meters. We can express a Newton meter. We know a Newton meter is in joules, so we could actually get rid of Newton meter and put it in joules. Or we could actually divide this by 1,000 and see that this is 21.3 kilojoules. And for this problem, we're given 3 sig figs. Sorry about the mass. Assume that that was 3 sig figs as well. But we get 21.3 kilojoules for the firefighter.